In order to create my rain alert Python script, I want the script to be run every morning at 7 a.m. Let's say that I'm going to head out of the door at 8 a.m. in order to go to work. I want my script to run at 7 a.m., check the weather for the next 12 hours, so the time when I'm going to be away from home, and then send me a text message if it's going to rain today so that I can remember to bring an umbrella. That way I'll get notified before I leave home and I'll know how to prepare for the day. The data that we got back from OpenWeatherMap contains the hourly weather forecast for the next 48 hours. So it starts from 0 and goes up to 47. Now we're only interested in the next 12 hours because if you imagine the script is run at 7 a.m. then plus 12 hours, that's going to be 7 p.m. by which time hopefully I'm already on the way home and I don't need to worry about whether if it rains or not. That's the goal, and if we head back into our code, what we want to do is firstly modify certain parts. Now we know that at the moment the response code that we're getting back from calling this API is 200, so it's successful. So we're going to call raise for status so that if there is a problem and we don't get a 200 code, then we actually raise an exception. Now, next, we want to save our response.json as the weather data. And then we're going to work with this data in order to get the particular pieces that we're interested in. So if we look at this JSON that we get back, firstly, we don't really care about the current weather or the daily weather. So when we look at the API documentation, which is probably the hardest part, making sure that you're diligent enough to read the entire documentation, there's often some good nuggets in there. For example, in this case, we can add another parameter called exclude, which allows us to exclude some parts of the weather data that comes from the API. This should speed up the API fetching process. It also means that we're transferring less data across the internet. So we can get rid of the current, minutely, and daily. We're only interested in the hourly. And we have to provide this as a comma delimited list. So if we take a look at their example, you can see here they've said exclude, and then they've said hourly, comma, daily. And notice how it says without spaces. So as I always say, this is like going into somebody else's house. Everything is different. The way that the washing machine works is different. The way that their dryer works is different. So you really have to look at the API documentation when you're working with a new API, just so that you're not caught out and you understand exactly what you have to do in order to be a good API user. Let's go back into our code and let's provide that extra parameter. So that was called exclude. And the thing that we want to exclude is going to be provided as a string. So we want to get rid of current, minutely, and daily. So we're going to add that into the string and make sure that we separate each with a comma and without spaces. Now, when we hit run and when we get back our weather data and we print it out, and we copy this and put it into our online JSON viewer. So let's replace all of the stuff that was there before. And you can see the JSON we're getting back is now a lot simpler. We're only getting back the hourly weather forecast. So that's step one done. The next step is to dig through this hourly forecast and get hold of the thing that we're interested in, which is the actual weather condition. The way that weather services tend to provide the weather condition is through an ID. And I know this because I read the API documentation. It's not because I'm some sort of weather geek. Although, I mean, that's not a bad thing to be, I guess. If we take a look inside the API key, if we scroll down in this documentation past the examples, you can see it provides all of the fields in the API response. So these are all of the things that we could possibly get back and what they mean. And you can see there's some really interesting things like the UV index, or you can get what does the temperature feel like based on the wind chill and actual ground temperature. But what we're mostly interested in is the hourly data, and then inside that, the hourly weather data. So this hourly weather ID is a weather condition ID. And when you click on that link, it takes you to this table that shows you all of the weather condition codes that we could possibly get back in this particular field. Now, you can see that all the codes that start off with a 2 means some sort of thunderstorm. And then starting with 3, that means some sort of drizzling. Starting with 5 means rain. Starting with 6 means snow. And then afterwards, we have the 700s. So these are atmospheric things like a bit of mist, a bit of smoke, a bit of dust or fog. And this is also, incidentally, the reason why this weather key actually has a value that's in the form of a list. You can see that's denoted by the square brackets here. So there could actually be multiple weather conditions for a particular place at a particular hour. And that's because you could maybe have snow, but you could also have fog at the same time. Now, when I looked through a lot of the examples and the documentation, it seems like the first item in that list is the main condition. So if it's going to rain, then it's going to be in that first item in the list of weather conditions. Inside that list, we have a dictionary or many dictionaries. Each of those contain a weather condition ID, the main condition name, and the description. So if we look at this ID code 802, we can decode it in this table, and you can see it means scattered clouds. 20 to 50% of the sky is covered in clouds, basically. Based on this list, we can say that, well, anything that has a code less than 700, then we probably will need an umbrella. I'm not sure how you stand on the umbrella in snow situation, but I personally do like to hold an umbrella when it's snowing, especially because I live in a country where the snow is not crazy. It's just sort of, it's never sort of the beautiful snow where it's thick and it gets caught on your eyelashes. It's the sort of annoying slush that's just sort of snow, but it's sort of like somebody spitting at you. So in my case, I would prefer to have an umbrella if it was going to snow. I'm going to check for the codes that we get back from the OpenWeatherMap API. And if the code is less than 700, then I'm going to advise my user to bring an umbrella. Here's a challenge for you. Can you figure out how to look through the data that we get back, which, remember, looks something like this, get hold of the first 12 items from that hourly list, and then look at the weather and the first item in the weather list and also the ID. So you're going to go all the way down to this, but remember you're going to do that for all of the items and you're going to check for the condition code. Now, if any of those ID codes are less than 700, then you want to be able to print out, bring an umbrella. So that's the goal. And the actual implementation, I'll leave up to you because there's quite a few ways that you can do this, but I'm sure by now you're well prepared with all of your tools in Python to figure this out. If you want to make sure that your code is actually working, you can switch to a latitude and longitude that is definitely raining. So if you go to venturesky.com, they actually show you the live weather forecast. So we can look at precipitation, which is basically rain, and we can find some sort of unfortunate place which seems to be really heavily raining. For example, this place in Poland, Łódź, and if I spell that name correctly, Łódź, and then I'll add the country code, Poland. And just to make sure in the map it's actually found the correct place, yeah, that looks pretty much it, then I can switch out my latitude and longitude with this rainy place. And that way I know that at least one of the results I get back is definitely going to contain some sort of rain. Now, if we look at their hourly data, you can see that the weather is basically just rain, rain, rain. So between looking at places which are sunny and places which are rainy, you should be able to get your code to work so that it tells you in the next 12 hours if any of those condition codes are less than 700, which means it's got some form of precipitation. Pause the video and give this a go. All right, so let's narrow down into this weather. If we want to get the weather for the next hour, then we have to tap into the first item in our hourly list, and then we get hold of the weather, and then we get hold of the first item in that list. Under the ID key, we'll get the actual value. We've talked about this in detail in previous lessons. If you've skipped a lot of lessons and you've come here directly, then it's going to be a little bit confusing, and I recommend to review the previous lessons before you continue. Instead of printing the weather data, let's drill down. Let's get to the first item here, which is hourly. If we provide a set of square brackets, and then we can access the value inside the hourly key, like this, and now we've got a list with all of the hourly data, and it looks pretty much like this. Now you can confirm this by also pasting this into the JSON viewer, replacing the previous text that was there. You can see we now have our 48 items in this list of hourly data. To drill further down, let's get hold of the first item in that list by providing a square bracket and then the index, which is 0. Now we're into the first item, and this is what the data looks like. It's a lot shorter. Now we want to tap into the weather condition. So that means yet another set of square brackets and then the name of the key, which is weather. Now it's pretty simple. It's simply giving us a list with only one item. Let's tap into that one item by using, again, square brackets 0. And now we've got just a simple dictionary, essentially. So if we want to get hold of the ID, then it's the final square bracket and the key, which is ID. The current weather data ID code is 500, and that, of course, refers to light rain. The next problem is, how do we get hold of the first 12 items that we get back in our weather data? In previous lessons, we covered the Python slice function, which could work for this by simply providing a value and slicing a sequence like a list or a tuple to get hold of a particular section of that list or tuple. Now, you can also use the Python slice operator, which is the square bracket and a colon. And this is probably a more Pythonic way of doing things. And you'll see more people doing this in the wild than using the slice function. So let's do it with this notation. We're going to use this version. So we're going to tap into a list and then provide a colon and then where we want to stop, because we want to go from the beginning of the list through to stop -1. We know that it's this part of our code that gets us to our list of hourly weather forecasts. So we want to create a slice from that data. So let's copy that and comment this line out. And then I'm going to create my weather slice, which is going to be generated from the weather data under the key called hourly. If I print this, you can see it starts off just simply being a list with all of the weather forecasts. Now, if I go ahead and slice this, I'll use that syntax that you saw earlier on, where we have a square bracket, a colon, and then where we want our slice to end. And we want this slice to go from 0 all the way up to hour 11. So that's 12 hours in total. So if we want to go up to 11, then we have to put 12 in here because it's going to be whatever number here -1. And now if we print this data that we get back, and we replace the existing text inside our JSON viewer, then when we take a look at it, you can see we've got the next 12 hours of weather data from 0 to 11. Once we've got that slice, the next step is, well, how do we get the rest of the stuff, right? What if I created a new list that contains the condition codes? We know that we've got a list of all of the weather conditions for the next 12 hours. How can we loop through that list to find out the actual ID of the weather condition for each of those hours? Well, we can create a for loop that looks at each of the data from the hour. So for hour data in weather slice. So this is going to go through each of the 12 hours. And then for each of those hours, we're going to tap into the hour data and try to get hold of the item that is in the weather key. Like this. Now I'm going to print each of these, and you can see we've now got a list of all of the weather conditions for each of those hours. Now let's narrow down that a little bit further. Let's get hold of the first item of each of these lists. And you can see, in fact, there's only one item in all of these lists. It's very rare that you have multiple weather conditions for each hour. Now that gives us a Python dictionary for each of those hours, and we can tap into that final value we're interested in under the key ID. So now we've looped through the next 12 hours and got hold of the weather condition ID for each of those hours. Now all we need to do is to save this instead of printing it, and we'll call it the condition code. And remember, previously we said that if the condition code is less than 700, then we're going to print bring an umbrella. So we can check if condition code, which remember at this point is still a string, so we have to turn that into an integer in order to be able to compare it against another number. If that condition code as an integer is less than 700, then we're going to print bring an umbrella. And you can see that for the next 12 hours, there's 6 hours which are going to rain at this particular place in Łódź in Poland that I've put into the latitude and longitude. Now, if I don't want to call this print statement many times, then we can define a variable outside the for loop called will rain, and we can set that to false to begin with. Now, if during the next 12 hours the condition code is less than 700, then we'll switch that to equal true instead. Now, after the for loop has completed, then we can check to see if it will rain in the next 12 hours, and if so, it will print bring an umbrella. This way, we'll only get one print statement being called instead of every single time we land on a condition code for rain. So this involved quite a bit of JSON parsing and also understanding how to work with parameters and APIs. Now, I hope you managed to get this far by yourself, but if not, be sure to review what I've written and fix your code as required. If any of it was confusing, be sure to review previous lessons before you continue, because we're now building heavily on your previous knowledge that you learned through the course. Now, in the next lesson, we're going to be looking at how we can, instead of printing bring an umbrella, to send a SMS text message that notifies you to bring an umbrella instead. So for all of that and more, I'll see you on the next lesson.